Tuition Mobile, quality e-learning experience on the go.
In continuation to previous classes, we had about sets. We'll be talking about drawing of Venn diagrams. Drawing of Venn diagrams. Venn diagrams. Alright, I want to believe that from previous classes we have grabbed the meaning of Venn diagrams and what they represent. Alright, sometimes you may be given the description of some sets and you are asked to draw a Venn diagram to represent the set. First, all we need to do is to determine the relationship that exists between the sets of values. First, we determine the relationships. Determine the relationship that exists between the sets that exists between the sets of value. Alright. Okay, and we have to determine relationships like whether they are subsets. What we look out for is whether they are subsets. Are they subsets? Subsets, or are they intersections, or are they intersections? Okay, and if there are intersections, what happens? Okay, all right, but there could be several ways of to describe this relationship. All right, for example, if you are given a Venn diagram of this nature, okay, and A is drawn within B, assuming you're given a Venn diagram that looks like this, right? And then you have another Venn diagram, another cycle inside, and this is my set of A, and this is set B. All right, good. And you have to know that there is possible relationship existing within this diagram, and the possible relationship here states that A belongs to B, set A belongs to set B. Okay, good. And this implies that it is either A is a subset of B. These are the possible things. Either A is a subset of B, or A union B is equal to B, or that A intersection B is equal to A. Okay, these are the possible relationships that will exist in set of this nature. Okay, these are the possible relationships that could result to sets looking in that form. All right. But in case you're given an overlapping Venn diagram of overlapping sets, say in this nature, you're given a Venn diagram of overlapping sets like this, okay, and you're told that this is B and this is A. All right. So we know what makes this overlapping occur. Okay. Alright, so this really implies that some members of set A belong to B, or it could be that A intersection B is not equal to a null set. Okay, good. This is a possible relation too. Okay, and the first one we stated that some members of A belongs to B could be that A union B. This could be A union B. You know, that could result to this. All right. Or you can as well write this as and A intersection B is not equal to 0. Okay, there are members in A that are in B, and so that brings about the overlapping of sets A and B. Okay, I hope you wouldn't forget that when we have this, it is used to denote a null set. And we said something in our first class that a null set is a subset of every set. A null set is a subset of every set, a null or empty set. Okay. But if we are given sets, if sets are drawn in disjoint, okay, assuming I subtitle it disjoint sets, alright, disjoint sets, okay, maybe set A, set B, okay, they're just on their own, okay, we call them disjoint sets, and this implies that no member of A belongs to B. Okay, this actually implies that no member, okay, of set A belongs, alright, belongs to B. Or we can say that A intersection B is equal to a null set, or it can as well be written as A intersection B equal to 0. Alright, so these are the relationships that exist between sets pictorially when you just look at the Venn diagram, and then it speaks of a relationship, and then you can be able to know what kind of relationship that exists between them. Are they adjoint sets, or are they disjoint? Okay, or are they a proper set, or and all other relationship. And this brings us to the end of the theory of sets. To have a good understanding. It's my wish for you. Good day.